So in this video, we're going to take a look at triangle inequalities. Now, triangle inequalities deals with the different sides and angles of a triangle. In particular, we're going to take a look at the sides. Now, actually, you can't use any three numbers for sides of a triangle. Just because you have three different sides doesn't mean it can make a triangle. Let me show you what I mean. So let's take a look at this picture, for example. We recognize this is not a triangle. Notice that this side is not long enough. Now, if I were to extend it, I could make a triangle, but as it is right now, there is no way for me to configure these sides in any way where I'm having them sit at the endpoints here and to make a triangle. Okay, so some of you might be like, whoa, what if we move this over here and we just kind of swing it down? And look, it's a triangle. Well, yeah, but that's not including the entire segment length here. So when we're talking about triangle inequalities, there's actually a rule about what can be a triangle. And this is the rule. We'll put it out in words here in a minute, but let's just talk about it. A triangle can only exist as long as the two smallest sides are longer when you add them together than the biggest side. So think about it something like this. Let's say we've got a triangle here. And this is our longest side. We'll just say it's a right triangle, but it could be any triangle. That's our hypotenuse. Now, let me ask you this. Say this was on the ground, maybe like on a football field or something, and you were standing here at A. Which would be faster? Would it be faster to walk from A to B or from A to C to B? If you say you're going the same pace, would it be faster to go that way or to go around the corner here? Now, it's pretty obvious that A to B is going to be faster. The whole point here is that this is the longest side, but even as the longest side, it should always be faster, or shorter in this case, than taking the other two sides to get to that point. The geometry postulate here is that the shortest distance between 2 points is a straight line. And so a triangle goes from A to B in a straight line and then goes to B a different way through two lines that is not a straight line, and so it's going to be longer. So for a triangle to exist, the two smaller sides have to add up to be more than the biggest side. That's why this has to work. Now, we see this all the time. Well, maybe not all the time, but if you ever go on a drawbridge, okay, the bridge is flat and it starts to open up, but it's not a triangle. Notice there's space here, right? And you might have seen it in a movie where somebody takes their car and they're like, I'm an expert artist here. Here's their very fancy car. Perfect. Look at that. All right, they take their car and they're like trying to ramp it off the drawbridge to land on the other side. You get the idea, okay? But the idea here is that these added up together would be equal to the bottom side, okay? And when they come down, they come together, but when they go up, they never make a triangle. So again, this is just a real world example of where we see triangle inequalities. So how does that play out, okay? Here's the official definition. If you want to write this down, you're welcome to. But let's do a couple math problems dealing with this. So in triangle inequalities, we know that two smallest sides of a triangle must add up to be bigger than the third side. So say these are three sides of my triangle. If I want to check and see if this is possible, I add the two smallest together. 12 plus 15, that gets me 27. 27 is bigger than 25. So that could be a triangle. So let's look at maybe two more here. So I've got 4, 7, and 2. Can those be a triangle? Now, it might be tempting to add the 4 and 7 together, but that wouldn't be right. We need to add the 4 with the 2, right? Those are my two smallest sides. And I get 6. 6 is not bigger than 7, so this could not be a triangle. All right, what if I've got 12, 9, and 3? I'm going to add the 9 and 3 together. I get 12. Is 12 larger than 12? It is not. If you have equal, the two smallest equal the biggest side, that's still not a triangle. They have to be bigger. All right, well, last one here, and then we'll look at one other variation on this. All right, so I've got 5. What should I add it with? Well, it doesn't matter which 8 I add it with, right? I'm just going to add these together, so this comes out to 13. 13 is bigger than 8. That checks out. That works. This would just be an isosceles triangle, though, right? Because I've got 2 sides that are equal. So, all right, hopefully that's pretty simple. You guys, this should be a breeze to do problems like this. Let's look at one variation, though. What if I give you 2 of the sides, and I want you to find me the range for the possible third side? Well, we're going to think about this 2 ways. We're going to think about what is the biggest that third side could be and what would be the smallest that third side could be. And I'm going to kind of work this out, and then I'll show you the really fast way to do it, but just kind of think this through with me. Let's say the third side is the biggest side. Well, then these are my 2 smallest sides, and I need to add them up. And so 6 plus 8 would get me 14. Okay? That has to be bigger than my third side, right? If it's the biggest side, it has to be bigger than x. We'll just call it x. All right? So my biggest side, it could be up to 14. It can't be 14, but up to 14. Now let's think about, what if that x side is my smallest side? That would make 8 my biggest side. So I could think of it like this. X plus 6 has to be, man, that was real ugly. Let's try that again. X plus 6 has to be greater than 8. And so notice, I'm going to subtract 6 on both sides, and I get x has to be bigger than 2. But this actually works out really, really well. Okay? Notice what we did on one side. We did 8 plus 6 on one side, and here we did 8 minus 6 on the other side. And that's all we're going to do. If we've got 2 sides, we're looking for the range of the third side, add them on one side, subtract them on the other, done. So let's look at 1 or 2 here. So I've got 17 minus 14, or let's do the plus side on this side, and I get 31 on one side, and I've got 17 minus 14, and I've got 3 on the other side. Done. X is somewhere between 3 and 31. It can't be 3, it can't be 31, but it's somewhere in between. Last one, notice now I've got 2 sides here, so I'm going to add them on one side, and I get 20. I'm going to subtract them on the other side, and I'm going to get 0. And my x value is going to be somewhere in between those 2. Let's look at one multiple choice question dealing with this. This is another way this problem sometimes shows up. All right, so John wants to build a swing set. He has boards of 7 and we'll say 7 feet and 12 feet. What could be the possible length of the third board? It's probably going to be kind of a not very good swing set if he's just grabbing random boards. You usually have to be a little more careful, but we'll let John do his thing. Let's go ahead and see if we can figure this out. So once again, I'm going to add these up on one side. I get 19. I'm going to subtract these on the other. I'm going to get 5. And I know my answer is somewhere in between them. Now notice, I have 5. I have 19 as an answer, but can that be the size of the third board? No, it has to be in between 15 and 19. So this is not the right answer. That's not the right answer. The correct answer here is 9. I could have picked anything, any of these would be the right answer, or I could pick lots of numbers for the right answer. 6, 7, 8, 9, 10, 11, anything between 5 and 19. 5.1 could have been a right answer, all right? So when you're doing these, a lot of times kids will get to this spot right here, they'll see the 5, they'll say, oh, that's the answer. No, remember, we want between 5 and 19. So this is that wraps up the first part of solving for solving triangle inequalities.